let's go ahead and do a practice problem with delta H stoichiometry. So the first thing we're going to want to do in this problem is we're going to want to balance our chemical equation. So go ahead and pause the video if you want to copy down the problem and if you want to balance this equation on your own. So when correctly balanced, this should be a 4, O2 should be a 5, and O should be 4, H2O should be 6. It's not possible to solve these problems if our equation is not balanced properly, so it's very important that before you try to do any stoichiometry that you make sure that your equation is balanced. So now we can go ahead and get to the stoichiometry. We're going to start with our given value, which is 155 grams of NH3. So we know we can't get from grams to kilojoules, but this value here is for the reaction in terms of the molar ratios of the reactants and products. So we can use moles to get to energy. So in order to get to moles, we need to do a conversion. So in order to do that, we need to figure out the molar mass of NH3. So for nitrogen, we have 14.01 grams per mole times 1. We have 3 hydrogens, each at 1.01 grams per mole. For a total of 17.04 grams per mole. So that's our molar mass of NH3. So we're going to put grams on the bottom so it cancels. So now we're in moles. We know we want moles of NH3 on the bottom, and we know we want kilojoules on top because that's what we're trying to solve for. So the value that we want for moles of NH3 is we really want to use this molar ratio right there, because whenever this molar ratio is 4, that's what the kilojoules or the heat that's being released is going to be. And that's given for this reaction. So it's going to be 4 moles of NH3 to negative 906 kilojoules. So go ahead and take a minute to solve that. When you solve that equation, you should get that your answer is negative 2,060 kilojoules. And is heat being absorbed or released? Well, we have to look at the value of delta H of our reaction. And because that value is negative, it tells us that the reaction is exothermic, so that heat is being released.